Hi, Miss Lekbu. For my calculus final, I'm going to go over the third FRQ. So the depth of seawater at location can be modeled by a function h that satisfies the differential equation dh over dt 1/2 h minus 1 cos t over 2, where h over t is measured in feet and t is measured in hours. After noon, t equals 0. It is known that h0 equals 4. A portion of the slope field for differential equations provided. Sketch the solution curve y equals h over t through the point 0 to 4. So looking at the slope field, you just do a line starting from this point at 0, 4, and you follow through like this, because it's the best prediction of what the question is asking. That's A, that's it. And for B, for 0 to t to 5, it can be shown that ht is greater than 1. Find the value of t for 0 t5 at which h has a critical point. Determine whether the critical point corresponds with the relative minimum, relative maximum, or neither relative minimum or relative maximum for the depth of seawater at the location. Justify your answer. Okay, so the first thing you do is you write the equation. And this is since h over t is greater than 1, this will never be 0. And the other equation is 0 cos t over 2, and cos of x equals 0 when x equals pi over 2 and 3 pi over 2. So t is going to equal pi or t equals 3 pi, but this is not in the interval. So there is a critical point at t equals pi since dh dt changes from positive to negative at t equals pi. H has a relative minimum at t equals pi. And this is because if you do the I forgot what this is called, the graph thing for dh over dt and h, you plug it in, this is what you're going to get. That's why it's a minimum. Okay? All right, for C, use the separation of variables to find y equals h over t. The particular solution to the differential equation dh over dt equals 1/2 h minus 1 cos t over 2 with the initial condition of h is 0 equals 4. So first you would write the equation again. So dh over dt equals 1/2 h minus 1 cos t over 2. And then you find the antiderivative, which is 1 over h minus 1 dh equals 1/2 cos pi over 2 dt. And you're going to have to use the e method thing. I kind of forgot what it was called, but it's going to look like this, equals sine t over 2 plus c, and then you e both of them, and then you're going to end up with h minus 1 equals big C e sine pi over 2. That will leave you with 4 minus 1 equals c e sine over 2, because you have to plug it in. And then you're going to be left with 3 equals c e 0, and that should be equal to 3. So then you would plug it back in into the original equation. Equals 3. You move the 1 to the other side, so it's going to look like this. And then you're going to be left with h over t equals 3e sine pi over 2 plus 1. That's your answer. Thank you.